All right. Okay, the first one here, it says write an equation of y equal absolute value of x. Now, this is what we're going to do. We're going to shift it right 1 and then down 6, and it's been reflected across the y-axis. Okay, so let's start our equation out, and let's just leave it blank so we can add stuff to it. Okay, so let's go right 1. That means we're going to say minus 1 on the inside because it's horizontal. Horizontal stuff's on the inside. Down 6, so we would subtract 6 on the outside for the vertical stuff. Now we'll have to think about this one a little bit. If I go across the y-axis, that's horizontal. So reflecting means we have negatives, and if I'm reflecting it horizontally, the negative goes on the inside there. Okay, number 2. All right, let's really the same type of question here. Let's just start off with that. All right, so here we go. Write 5. What's that going to mean there? Minus 5, and then down 8 would be minus 8 out here. Now this one says reflecting across the x-axis. So that means we're reflecting it vertically. So y'all can tell me, where's the negative sign going to go? Outside. Okay? Because it's doing vertically. Vertical stuff goes on the outside. All right, number 3. And then y equals absolute value of x again. Okay? So let's see, right 4 units. That means we're going to say minus 4 on the inside, because we're going the opposite direction when we do horizontal stuff. And then up 1 plus 1 on the outside. And then that one didn't have any reflections. Okay, usually these first few questions are easy. Now, number 4, though, we talked about this one yesterday. Really what we're going to look at is we're going to focus on that vertex. And let's describe how we're getting to that vertex. So from the origin there, to get to that vertex, I'm going 1, 2, 3 units to the right, and then 1 unit up. Now, the other thing that we have to notice about it here is the graph is upside down. So since it's been upside down, what's happened here is it started off like this, and it had to be reflected vertically. Okay, so it was reflected vertically, or we could say right there it was reflected across the x-axis. Now, so really what I've done there is I've just turned it into a problem like we had earlier. So if we go 3 right and say minus 3 on the inside, up 1 will be plus 1 here. Okay, and guys, tell me this one. What about reflected vertically? What are we going to throw in? Again, negative on the outside. Okay, so what's really going to tip you off on that negative on the outside again is it's going downwards. Okay, anytime your graph is going downwards, you're always going to have a negative on the outside. Okay, negative on the inside doesn't do that. Okay, so you don't have to worry about the negative on the inside like a question like number 4 there. All right, now 5. Here's where we're starting to do the graphs. Okay, this one says, all right, we're going to translate. So this would be 2 units to the left. It's going to go in the opposite direction there. Dilates by, well, this doesn't have a dilator. Now, since it doesn't have a dilator, it's not going to be skinny or wide. It's just going to be like the standard width there. All right, reflects across the y-axis. So I don't see any negative sign on the inside or the outside. So it doesn't reflect across either there. And this is going to translate right there 3 units down. Okay, so now it's our t-table. And I'm going to do this to make it faster. All right, and then on my y side here, all I'm doing was just taking the absolute values on those. Okay, so this is like we start with this, Deja, like every single time. Okay, this is what I'm always starting with. Now it's going to change though. All right, so let's make all these changes that we've noted on these questions, and y'all on the test. What I'm doing by asking you these questions, the thing is, if you miss one of those, your graph's going to be wrong, isn't it? And then one little thing is going to make your graph wrong. So what I'm doing by asking y'all those questions and making you do that, even though you might miss your graph, you can still get partial credit. Okay, so that's why I ask you those questions like that. Now, let's do 2 to the left, all right? So that means we're going, the left is the x, so we're going to take all the x's and subtract 2 from them. So negative 2 minus 2 is negative 4, negative 1 minus 2 is negative 3, 0 minus 2 is negative 2, 1 minus 2 is negative 1, 2 minus 2 is 0. Okay, so got that one. I didn't have anything to do on that one, or that one, or that one. Now let's go 3 units down. So we'll take all the y's, and I'm going to subtract 3 here. So 2 minus 3 would be negative 1. 1 minus 3 would be negative 2. 0 minus 3 is negative 3. 1 minus 3 is negative 2. 2 minus 3 is negative 1. Okay, so of course all you have to do now is throw them on the t-table. Do y'all want me to graph them on the video for you? No? Okay. I might graph the one with the thirds on it, just so my other classes can see it. Alright, yeah, we'll probably graph this one. Alright, so let's do, I'm going to do this a little bit faster. We're going to translate 5 units to the left. We're going to dilate by 1/3, and notice I'm saying not negative 1/3, just 1/3. And now because that's a smaller number, it's smaller than 1, that's going to make the graph wide. Okay, now I've got a reflector in it. Now the negative is on the outside, so if it reflects vertically, that means it would go across the x-axis, not the y-axis though. And it translates, let's see, 2 units up. So let's do all our transformations now. So let's go 5 left, so we'll subtract 5 here. Alright, got that one. Alright, let's dilate by 1/3, so I'll multiply all the y's by 1/3, so that would be 2/3. 1 times 1/3 is 1/3, that's still 0. 1 times 1/3 is 1/3, 2 times 1/3 is 2/3. Okay, I'm not going to do that one. Reflects across the x-axis, so that means I'll change all the signs on the y's. Alright, now we're going to shift 2 units up. So I'm going to add 2 to all these fractions. So if these fractions confuse you here, get your calculator and punch in. Punch in negative 2/3 plus 2. So let's see, that should give you 4/3. And then negative 1/3 plus 2 would be 5/3. 0 plus 2 is just 2. And now I'm going to cheat on these two, because I'm noticing here that all these are always the same, these two are always the same. So this is 5/3, and this one's 4/3. Okay, now this graph I'm going to actually do for you because it's a little bit confusing with those thirds. Alright, so what you can do to make this graph easier, notice that on the y's here, almost everything is in terms here of thirds, okay, with the exception of the 2. So what I can actually do here is change what I'm counting by to make it easier to graph. So instead of counting by what my really graph is counting there by as ones, is we can count that graph by 1/3. And all you have to do to show me that on your test here is put a little mark beside the first one that says 1/3. And now that's counting by thirds. Now the x's, since these are just nice integers over here, you can just count by ones. Alright, now one thing I'm going to have to account for here is this 2 I'm going to have to think of in terms of thirds. Now 2, if I thought of it in terms of thirds, what divided by 3 would give me 2? And that would be 6. 6/3 would be 2. So now it's going to be much easier to graph here if I count my y-axis by 1/3. So here we go. Let's go negative 7 and then 4/3. So 1, 2, 3, 4/3 there. Okay, negative 6 and then 5/3. 1, 2, 3, 4, 5. Okay, and then negative 5, 2, or negative 5, 6/3, what I should say. So negative 5, 1, 2, 3, 4, 5, 6. All right, negative 4, and then 5/3, 1, 2, 3, 4, 5. And then negative 3, 4/3, 1, 2, 3, 4. And so counting my graphs by 1/3 here makes that so much easier to do. So you can always, in this class, you can scale your graphs by whatever you want to, as long as you show it right here. Okay, just show what you're counting by, and that's all you have to do to modify that. Okay, number 7. Let's go through our questions here. All right, we're going to translate. This would be right here. I'm adding 3 in the inside, so it's going to be 3 units to the left. We're going to dilate by, we're multiplying by that 2. Now, that 2, that's a number that's bigger than 1. So that's actually going to make the graph skinny. All right, let's see what it's going to reflect across. So I only have one negative side. The negative is on the inside. So if it's on the inside, that means it reflects horizontally, so it would go across the y-axis, not the x-axis. And now we're going to translate it there, 4 units down. All right, let's start with A there. Translate it 3 units to the left, so I'm going to subtract 3 from all these. All right, dilate by 2. And all the dilators you're going to get, they're on the outside, so you always do them by the y's. So multiply these y's over here by 2. So that will be 4, 2, 0, 2, 4. Check them off as I do them. All right, reflects across the y-axis. So we'll change the signs of the x's here. These will change positive for me. Okay, didn't really have to do D. All right, translates 4 units down, so I'll take all the y coordinates over here and subtract 4. 4 minus 4, 0. 2 minus 4 is negative 2. 0 minus 4 is negative 4. 2 minus 4 is negative 2. 4 minus 4 is 0. Okay, that graph should be fairly simple there. All right, number 8. Let's see, this one's going to translate there 4 units to the right. It's going to dilate by that 3 right there. Notice I'm saying 3 and not negative 3. Now because that's bigger than 1, that's actually going to make it skinny. All right, reflectors here. Now notice I have a negative on the outside. So if I have a negative on the outside, it means it reflects vertically. And so that would have to go across the x-axis. So yes on the x, but no on the y. The y would have had a negative on the inside there, like our last problem did. And translate, notice that we're not adding or subtracting anything there, so it's not going to go any up or down. So I'm just going to do none right there. All right, so let's go back on A. We're going to translate 4 units to the left. So let's subtract 4 from the x's. 0 minus 4 is negative 4. 1 minus 4 is negative 3. 2 minus 4 is negative 2. All right, let's dilate the y's here by 3. So we're going to multiply the y's by 3. It'll be 6, 3, 0, 3, 6. Now we're going to reflect across the y-axis, so that would change the signs of the x's. It didn't reflect across the y-axis, did it? Were y'all watching me do that? Did I just mess that up? Okay. So these were negative, weren't they? Okay. I changed the wrong signs, didn't I? Okay. So it did not reflect across the y-axis. It reflected across the x-axis, so I got to change the y's. All right. There we go. That's right. All right. And now trans doesn't do anything up or down, so I'm done. All right, last one. Okay, so it translates. Notice I don't have anything on the inside there, so it's not going to move any left or right. It dilates by half. Now, because that's smaller than 1, that's going to make it wide. It reflects across the y and the x-axis. I don't see a negative in front of the 1/2 or a negative on the inside there. So it's not going to do either of those. and it's going to translate 3 units there down because it's negative. Okay, so let's do our transformations here. So nothing to do on part A. Part B, let's dilate by half. So y is by half here. 2 times a half is 1. 1 times a half is a half. That's still 0. 1 times a half is a half. And 2 times a half is 1. All right, no reflections. Now we're going to translate 3 units down, so we'll just subtract 3 from the y's. 1 minus 3 is negative 2. 1/2 minus 3 would be negative 2.5. 0 minus 3 is negative 3. And then again, 1/2 minus 3 would be negative 2.5. And then 1 minus 3, negative 2. Do y'all want me to look at this graph for the fraction's sake on this one? Halves really aren't that bad because like halfway, you just go, what, halfway, right? Okay, so that one, I don't think I would really count my y's by half there. It's like when you get like thirds and fourths. Okay? Is this one okay now? All right, I'm not going to change it. So, all right, that's all, isn't it? All right. Does anybody want to come up and say goodbye? You guys say it louder than that.
Follow me on Twitter.